Hello, and welcome back. This video is about making a noisy edge material. And a special thanks to all my supporters. Thank you for helping me help others. So to start, this is just a first-person project blueprint, and I just added a new basic map. So we're going to start by creating a material. Call this m_noisy edge. And in here, I'm just going to change it to masked blend mode. I'll hold T and click to get a texture sample, which I want as the noise texture that's included with Unreal. T_noise01. Just drag that in there. Save that. And then I want to create a pair of actors. So we'll start with a BP_noisy cube. In here, we want to create a static mesh. Drag it to root. Set it to a cube. I'm going to hit this save and compile always, so it's already set. Hit compile so I can see the material, and then add the noisy edge material. So with that, I'm going to right click, create a child blueprint class. We'll call this one noisy sphere. And in here, just switch the static mesh cube to a sphere. All right, for the cube, I'm just going to make it 2x2 scale. Actually, I'm not sure if that'll drag in properly. And then we're going to drag these in and drag that up, hit end to pop it down. Same thing with the, that was the material. Same thing. And same thing with the sphere. All right, I did that wrong. Let me reset this back to 1. All right, I want this version here to be 2x2x2. All right, so that's 2 or 200, and this one is 300. I want them to both be close to the camera. That should work. And then back in our material, we want the world position. I'm going to take this value, subtract a parameter that we set. So to create a float parameter, basically, it's called a scalar parameter. So we can do that like that. For this parameter, we're going to call this our ValueZ. And this is what gets subtracted. If we just drag that into our opacity mask, you can see that the bottom here is now missing. I'm going to switch this to a cube so we can just look at it a little differently. You can see the bottom is missing. So instead, we're going to put a step in here. Which effectively reversed what was happening there. So effectively what's happening here is each of the pixels is going through this shader. For all the pixels, well, we just look at it vertically. The center here is actually the origin, so that's where the 0 is. So this is showing the bottom because this value going through the step, and the step actually can just be a 0 here as well. That's the difference there is just pixels. Everything that's below ends up turning into an opacity mask of 1.0. The output of step is always 0 or 1 based on the difference between y and x. So effectively, we're showing this cube based on what the value z is here. So at 0, which is the origin, and the origin of this default cube is in the center. That's why it shows the center. If we actually wanted to start at the bottom, I believe this cube is 128 or 256. So negative 128 would be the bottom. So you can see very little bit there when we have a negative 120. And then up at 120, it's going to be the top minus the actual top. If we throw it at 130, you can see that the top shows up. So we want our default value to start at 0, and then that's what we'll be changing in the actor. So if we do that, we start with just that. We can go into our noisy cube in our begin play. We can control drag out our static mesh. We call create a dynamic material instance. The source material is going to be this static meshes get material. And then we can just promote that to a variable. We'll just call this mi noisy edge. And then in our tick, actually before that, we set a variable. We'll just call this our ValueZ. Set this to a float. The initial value will just be 0. All we're doing here is we're taking our ValueZ. We're going to then add the delta value multiplied by the speed. For this example, we just use 25. For your own examples or own project, you're going to want to set that depending on how you create your models. And then with that, we can take our mi noisy edge and call set scalar parameter value. The name here is the one we set, which was ValueZ, and that would be this value. So when we run this, we can see that it starts at the bottom and it just basically goes up to the top. Nice and simple. Actually, I'm going to, oh right, so because the default value we have set, you can't actually see that in here. That's a little bit of a pain, but you can set this back here to just some very large number. And then you'll be able to see them here, no problem. I'm just going to rotate that a little bit so it looks a little better. Now to make that noise edgy, and actually now we want the value in here to be 0 so that we can see it happening over here. We're going to drag that back a little bit. I'm going to put an add node in here. And put that there. Actually, do that. So we want to take the texture. So we just copy and paste this. We're going to multiply this. I'm going to use a value of 50. This will depend on what the texture looks like. And that's the value that gets added in here. So as you can see right away, it's just using a noise value to add some variations in the way that the texture looks. To make that look a little more animated, we add a panner value, or panner node. We drag that into our UVs here, and then we can set these values appropriately. If we set this to 0.2, then the vertical value is basically changing. So what's happening is this texture here is being moved up. You can't see like this black part move because that's actually this texture. So even if we just remove that, it's basically this texture is moving up constantly, and then the opacity mask depends on the colors that are in this texture. So let's reconnect that. It's a little better. And then the other thing we want to do is we want an edge. So right now we have a noise on the edge, but if you want to also have an edge that has, a thicker size, a little more noticeable, then we can do that as well. So to do that, the value here is what matters. We're going to take this value. We're then going to subtract, but we're going to have it actually be -2. Actually, I can show you the other way. So if we have this here and then we have a 2 or -2 here, oops. We want to throw another step in here. We can zero that out because it doesn't really matter. So to add a color, we can do a constant 3 vector, multiply this by the output down here, and then send it to emissive. And we'll change this color to red. And here you see that the whole thing went red because this subtract node is wrong. So if we switch this back down here, and we do -2 here, then we get a 2 pixel effectively edge. So just to show that a little better here, if we set that to 5, then you can see it's thicker. Set to 25, negative, even thicker. So we'll set it back down to -2. And that's what it looks like. So if we do that and we run it, it looks a little better. Now, there are a lot of values in the material that you can play around with and get different results. For example, I have the value 50 here. If we set that down to 5, for example, you can see that is basically the amount of effect that the vertical panning is having. So a small number is going to have very small effect. You may like that. The problem with the larger number is that there's sometimes spaces down like that were cut into it that you may not want. So, using a smaller color works. You may like that better. Of course, the color is modifiable here. Color also can be modified up here. So if we then just copy and paste this one, we'll make this a blue color. And instead, we multiply and we have a nice blue color with the red end. And that's pretty much it. However, sometimes you follow some steps and then you do something slightly different and it turns out very different. If we skip the step node here, for example, we'll just drag that over here instead. And now we have a very bright fire effect, which looks pretty cool in here. If you actually run it, you're probably going to want to tone down the amount of emissive, because as it gets higher, it ends up being super, super bright. But nonetheless, it looks pretty good. And one last thing that I almost forgot. If we take our noisy cube here, which is basically on the ground, if we pop this up and then we hit play, you can see the problem that happens. So basically that number was starting at 0 and it goes up, and since the cube is higher up, it doesn't start that effect until here. So to resolve that, all we need to go is into our noisy cube. We just want to set our initial Z value, or value Z, to our get actor location. We can right click to split this. We're going to subtract in off. Oh, actually, I got to make it first. And duplicate this, call it offset Z. So we're taking our position, we're subtracting based on this offset, and then that's what gets initially set to value Z. So then the question becomes, what is the offset value? So for the cube, because the cube, well, you can't see it now, the cube is 200 by 200. So we want that offset to start at 100. The sphere is 300 diameter, so we want that offset to start at 150. There we go. And then make sure they're both good. And then when we start, the cube starts immediately because that value Z was set at the correct value. Just to prove that the sphere works, we can also just take that and raise it a bit. So as soon as it started showing it. Thanks for watching. If you liked the video and would like to see more, you know what to do. And if you would like to support this channel, watch these videos 2 weeks early, or just want to download the project files, you can do so through my Patreon linked below.